Hello viewers, welcome to Adam. In this question we are asked to derive the RMS value of a full wave rectifier. Okay, so let us start with the solution. So in a full wave rectifier, what happens? We give a AC input to a full wave rectifier. I am denoting the full wave rectifier by FW, and at the output we will get a DC output. Okay, so the difference in the half wave and the full wave rectifier is, suppose here at the AC input, we have a sinusoidal signal which has a positive half cycle as well as a negative half cycle. So in the half wave rectifier, it will only rectify the positive half cycle or the negative half cycle. But in the full wave rectifier, it will rectify both the positive half cycle as well as the negative half cycle. So in the half wave rectifier, the output will be like this. Okay. This all outputs are for positive half cycle. But in the full wave rectifier, the output will be like this. This is for positive, this is for negative, this is for positive, this is for negative, like this. Okay. So this is the basic difference between the half wave and the full wave rectifier. Now the question arises, how to derive the RMS value of a full wave rectifier. Okay. So let us start with it. So as I have said here, this is the output of a full wave rectifier. Okay. So this is a sinusoidal waveform. Suppose I am denoting it by Im sine of alpha. Okay. Im is the amplitude, is here. Im is the amplitude, and alpha is, I am considering sine of alpha is the angle. Okay. It can be anything. You can consider as sine of theta or anything, sine theta, sine alpha, sine beta. It can be anything. So this output waveform, okay, this output waveform, as we know, in a sinusoidal waveform, the total time period is 2 pi. The total time period is 2 pi, which means if the sinusoidal waveform is starting from this particular point at 0, then this point is the 2 pi. Okay. So 0, this point will be pi, then it will be 2 pi. So here the output will be also like this, 0, pi, 2 pi, likewise. Okay. So if we want to calculate the RMS value of a sinusoidal waveform, we need to calculate the RMS value for only one half cycle, because here we can see that from 0 to pi, the amplitude is positive, which is plus Im. But for pi to 2 pi, the amplitude is negative. Suppose this is minus of Im. Okay. So if we want to calculate the RMS value for this particular waveform, we need to do it separately for the positive half cycle as well as the negative half cycle, because the amplitude in both the half cycles are different. But if we look at the full wave rectified output, we can see that all these half cycle have similar amplitude. Okay, all these half cycle have the same amplitude. So doing the calculation for one half cycle will be same for doing this half cycle, and this half cycle too. So instead of doing the calculation for all the half cycle, we will just do the calculation for only one half cycle. So for the one half cycle, the time period varies from 0 to pi. Okay, so we can write I of RMS is equals to 1 by pi. Okay, 1 by pi, because the time period is pi only. From 0 to pi, as we are interested in finding the RMS value for this half cycle only, and this half cycle is time period for this half cycle is varying from 0 to pi. So we are integrating from 0 to pi, Im square sine square alpha. Okay, Im square sine square alpha, and this whole value will be under the root. So I am denoting the root by the power. Okay. So this is basically just root over I of RMS. So instead of writing root over, I am just writing I of RMS to the power half. Okay. So we need to do the calculation for this. So 1 by pi, 0 to pi, Im square. We know sine square alpha. Sine square alpha is what? 1 minus cos 2 alpha divided by 2 d alpha. Okay. To the power half. 1 by 2. Okay. So if we further extend the calculation, what happens is here Im square divided by pi, 0 to pi, 1 by 2 minus cos 2 alpha divided by 2. to the power, d alpha to the power half. Okay. So now we can see if we perform this entire integration, im square by pi integration of 0 to pi 1 by 2 minus cos 2 alpha divided by 2. So one thing we can do here is we can take 1 by 2 common here. So if we calculate here, okay, im square divided by pi, I am taking 2 common here, 0 to pi 1 minus cos 2 alpha d alpha, okay, to the power half. Right. So what happens here is if we done the entire integration, we will get im square divided by 2 pi into pi to the power half. Okay. So pi will cancel out each other. We will be left out with im square by 2. And if we perform the square root of it, we will be getting im divided by root 2. Okay. So the RMS value of a full wave rectifier is equals to im divided by root 2. Okay. So this is the required value of our question. The RMS value I of RMS is equals to im divided by root 2. Okay. Thank you.